implementing the k nearest neighbor in Python. K nearest neighbor regression in Python. What we need is to go step by step. First we will list here the various steps and then we will see the program. I have already written the program just so that we can speed up the process and keep a short video. At the same time I will share this program with you so you can try on your side. First will be import the libraries. Libraries we will need is the Scikit-learn library. We need pandas, we need numpy and we need matplotlib. Then the data collection, then comes the data preprocessing, then comes data preparation, then comes we can say data modeling using machine learning, and finally we will see testing. So there are sub steps, but these are the 6 major steps. So first step I will write, in which we will prepare our data. This is the data preparation step where libraries are imported. As I said, we will need the numpy library for storage. Even though we will not need it, but I have kept it imported. It is good to import all the libraries in the beginning rather than later. Then we will need the train test split from sklearn. This is to divide the dataset. Then we will need the main thing is the k nearest neighbor. So this is the machine learning model k nearest neighbor. Then for data preparation we will need the standard scaler. So I am writing data preparation. Then for testing we will need to check the performance on different metrics, and this is for the hyperparameter tuning. What is the meaning of all this? We have covered in the previous training, and better you can refer to those videos so that you can recall all these different concepts. Then the data collection. So data collection is already completed. We are using a ready database. The database is of handwritten digits. Okay, so in terms of machine learning, I will define the task. The task is to read the digit in the image, the digit, and predict the digit. So the digit will be from 0 to 9. Then there are 60,000 image. I don't know the number of images, so we will have to check. I am executing this Colab notebook. So Colab notebook is a Jupyter notebook. Jupyter or IPython notebooks. These are all having the same meaning. Okay. How this Colab notebook is created, how did I come to this website, I have already mentioned in the prerequisites. All our projects are on Colab notebooks or IPython notebooks or Jupyter notebooks. It means the same thing. Okay, maybe sometimes I will use Jupyter, sometimes Colab, sometimes IPython, but meaning is same. So here you can see we have 1797 images and 64, because 64, so each image is 8 pixels by 8 pixels. So the width of image is 8, height of image is 8. So total pixels will become 64. So remember what is a pixel. So we will see that in the next video. but pixel is any point located on the screen. Any point on the screen is a. Okay, so as I was saying, any point on the screen is a pixel, and each pixel has value from is in the range 0 to 255, because each color has is represented by a pixel using some number. So red color will have some number, black color will have some number, white color will have some number. So each pixel has that number which creates that color. So just to show you, you can see when I view the first rows of the X, I have pixel at position 0, 0, 0, 1, 0, 2 and so on. So 8 by 8 is the grid, and each point on that grid has a value between 0 to 255. Then Y, which contains the actual digit, so it is the digit that is present is from 0 to 9. Total 10 digits are present in the dataset from 0 to 9, more or less 180 image per digit. Just to plot a random digit, you can see this is the digit number. I think this is the number 8. Okay, so it is a blurred image because it is just 8 pixels. You can see 0 to 7 and 0 to 7. So this is the grid and 8 by 8 grid. Okay, each point is a image. So similarly, you can plot any point. Currently I have plotted the point number 500, but you can just change this number and plot any point on the data set. Next step is to divide the data set into train and test. So for that we have used the train test split function. In this function I have kept the ratio as 80 to 20. That means train will be 80% of the data and test will be the 20% of the data. So this we can confirm by seeing the shape. Stratify, it means that the ratio will be maintained, ratio of the different classes will be maintained in the test set. Okay, so I am writing here the meaning of stratify. So whatever is the ratio, suppose in data, the ratio of class 0 and class 1, let us say there are only two classes, is 4:1. Then in train and test, the ratio of the class is going to be maintained as 4:1 even in the train and test. That is the meaning of stratified sampling. Then we use standard scaler. Reason is that I want to convert all the columns or features of the data in the range, in a small range. So reason of using standard scaler is to convert the data, that is to convert the data to a small range. That means convert the data columns or features to small range. This is a standard step of data science. Although there are many ways we can achieve this, but I prefer to use standard scaler. But definitely there are other ways, other strategies of converting the data. So some people may recommend that you should divide the data by 255 in order to convert it to a small range instead of using standard scaler. So that is also a correct procedure. We can use that as well. Next comes the machine learning model. So this is the machine learning model, sklearn, k nearest neighbor classifier. If I search on Google sklearn KNN classifier, I come to this website. On this website, the parameters of the models are given. Okay, and these models parameters have to be finalized. They can have many values. For example, the weights parameter can have uniform or distance as the values. So these parameters have to be finalized, and for that we perform grid search. Okay, so here we have the parameters of the model, and we have to finalize the values of the parameters using grid search. So I just copied all these parameters list up to here above attributes. I went to ChatGPT, okay, and I wrote this prompt that to the ChatGPT. So I will just write ChatGPT prompt. Create a grid search list from the parameters. For each parameter, consider 5 options. Use KNN classifier, and scoring should be F1 weighted. Okay, so based on this, the grid was developed. This was the parameter grid. Now unnecessary some things have come up. For example, here the explanation of each parameter is given. If you know k nearest neighbor, then you will remember that everything depends on the number of neighbors. So these 5 values will be chosen. Then weight, either it should be distance based weight or it should follow some criteria. Algorithm for creating the tree should be from here. Leaf size, the distance measure, the metric to be used, and the number of processors to be used. These are the main settings. We will see these settings, which are the main settings from this. So all these settings will be tried in the parameter grid. Then we start the grid search. So here scoring, we will use the F1 score as the decision maker to choose the ideal parameters. Remember, F1 has many variations. The F1 weighted is when you have multi-class classification. That means I will just write here a small note that scoring for classification, because this is classification problem, use F1 for binary and F1 weighted for multi-class. This is just a thumb rule I follow, and I have seen some good results here. That is why to find out the other scoring metrics, you can simply type here sklearn scoring, and it will give you a list of scoring measures to evaluate the parameter grid. Okay, so for classification we have accuracy and so on up to clustering. Then for clustering we have these, and then for regression we have these. Okay, so these are the performance measures. I have chosen F1 weighted, and now the grid search will start. The grid search will be evaluated on the X train and Y train. The best parameters we will get, and the best model will be saved in this variable, and then that model will be used for the prediction on the test set. Then we will calculate the parameters that the model best model has generated. Parameters like accuracy, F1, precision, recall, and confusion matrix. Okay, so all of these parameters you will we have explained them before in the previous training, so you can refer to that, and in this way we have completed the getting the best model. Then the ROC curve, that prediction, ROC curve prediction will also be shown here. Now you can see that this will take a long time, because 300,000 fits, that means trials will be performed to evaluate the best model, which may take a few hours. We don't have the time, so I am stopping the training, but definitely you can continue the training After that you will get the best model here to plot the ROC curve and display the confusion matrix. Okay, so with that we have completed k nearest neighbor classification. You can try. Hello and welcome back. So we have seen k nearest neighbor classification. Now the same k nearest neighbor can be used for regression. Here we are importing a new data set. So this program I have continued in the same program. So the classification one is above and the regression is below in the same notebook. So we have to import the data set here. Some libraries already we had imported, so those we need not import again. But if we are writing this on a new notebook, then definitely we will have to import these libraries, all the libraries again. For now it is not needed. For this, the task that we have in front of us is to predict the price of the house in California. First we split the data and then we print the train and test split shapes, which is 15,480 and 5160 is the test data shape. Then there are no duplicates or missing values here, so directly we can go for standard scalar. Similarly, there is no non-numeric data. That is why we can directly go for standard scalar. Otherwise, we would have to do all those pre-processing steps. Then the k nearest neighbor regressor technique we will use. First, there is model selection and grid search. So the parameter grid for k nearest neighbor is nearly same as the classifier. We can, if I keep the same parameter grid, it is okay, but I am using a shorter parameter grid. Again, one major change is the scoring, which is negative mean absolute error. So regression scoring are given on this website of Scikit-learn. Here I will just type the website and then same steps are there. First fit on the train set, then get the best model and then apply that on the test set and calculate the regression testing matrices. So these are different. These are R2 score, mean absolute error and mean squared error. These are completely different matrices because it is a regression problem. R2 score is how much percentage of knowledge the model is able to understand. It has to be between, it should be ideally close to 1 and the range is negative infinity to 1. The range of the remaining matrix, that is mean absolute error, mean squared error, mean absolute percentage error, is from 0 to infinity. Ideally they should be 0. So that is it about this regression problem. We have given this to you. You can try, and if you have any questions, then definitely don't hesitate to ask. Okay? This notebook we are giving it to you for reference. Thank you for watching.